So this last one sort of illustrates that sometimes all the tips in the world, uh, sometimes they don't help, and we've got to think through possible ways to get a function into a state that we can integrate it. So here we've got the integral of cotangent cubed x dx. Now we had talked about a tip for when the power of tangent or cotangent is odd, and what we would do is we would borrow a tangent and a secant, or a cotangent and a cosecant in this case, to then set up our u substitution. Well, the problem here is that there is no cosecant of x to help as before with the example where our tangent was odd. So we're going to have to take a slightly different approach here. And the way that we're going to, we could kind of fight through this quite a bit, but oftentimes what we're going to need to do is start, if you get stuck, start maybe pulling off factors of that and seeing if you can get a problem that will work for us. For example, I would look at this and I'd say, well, what do I know how to integrate? I don't know how to integrate cosine cubed, but I know how to integrate cosecant squared. So maybe is there some way we can get a cosecant? And we're doing this by reviewing the very early on we had listed all of our derivatives. So we're asking ourselves, what do we actually know how to integrate? We do know how to integrate cosecant times cotangent, and we also know how to integrate cosecant squared. Anything else would probably involve another u substitution or possibly integration by parts. So thinking about that, we know how to integrate cosecant squared. What if we tried this? What if we pulled off, instead of the cubed, we pulled off one of those and we made it cotangent squared times cotangent dx. Now, getting an even power allows, kind of opens the door for us to use Pythagorean identities. So maybe we could write cotangent squared as cosecant squared x minus 1 using its Pythagorean identity, and then that leaves us with times cotangent of x dx. All right, so we still have kind of a tricky situation here. I mean, we might be thinking, well, could I possibly use integration by parts, or should I take a different path? In determining that, you could do something like, what if we distributed that cotangent through? Let's see if that helps. We're really just kind of trying different things here. If we distributed that cotangent through, we would have the integral of cosecant squared x times cotangent of x minus cotangent of x, and then all of this is integrated with respect to x. And I'm going to go ahead and break this up into two integrals. Cosecant squared times cotangent dx minus the integral of cotangent x dx. So we've got cotangent cosecant squared. If we think about it, u substitution is going to work in this case. So we can do substitution. Now we know that if we take the derivative of cotangent, we get negative cosecant squared. So if we let u equal cotangent of x, our du is going to be negative cosecant squared x dx. That's going to give us the negative integral of u du, which is going to be negative 1/2 u squared plus c, which would be negative 1/2 cotangent squared x plus c. All right, so we successfully have handled that first part of the problem. Let's now focus on this other integral to see if we've got a way to integrate it. So depending on your exposure to antiderivatives of trig functions in Calc 1 and what you've seen so far in this course in Calc 2, you may know the formula for this. And if not, we can talk about where that formula comes from. We know how to integrate this doing substitution. In this particular case, we would need to do substitution by rewriting this as the integral of cosine over sine. So we rewrite the cotangent using its quotient identity. And if we let u equal sine of x, du is going to be cosine of x dx, then we have the integral of 1 over u du, which is the ln absolute value of u plus c, which is the ln absolute value of sine of x plus c. It might be worth just remembering that. It's up to you. But it's not an awful use substitution if you had to do it on the spot. So now we broke it up into two integrals that we were able to handle. They both involved u sub, and now we're able to summarize our final answer as negative 1/2 cotangent squared of x minus the ln absolute value of sine of x plus c. So we have done a lot of different types of problems here, but the one thing that I think we could use to summarize here is a lot of these problems boil down to substitution. And getting to substitution requires us to use various trig identities to manipulate that integrand. So be comfortable with u sub and know your trig identities, and then you should be okay for these.